Okay, today, January 8, 2013, we learned about distance equals rate times time examples, and there are 5 examples. Example 1 is a catching up type of problem. So Ben takes a leisurely stroll. He walks at a constant rate of 2 miles per hour. Carrie starts out for a brisk walk 1 hour later. She walks at a constant rate of 3 miles per hour. How long will it take Carrie to catch up with Ben? So we're going to go ahead and make a table. Okay, this is the distance equals rate times time table. We have Ben and Carrie. We know how fast Ben is going. That's the rate. His rate is 2 miles per hour. We know how fast Carrie's going. She's traveling at 3 miles per hour. Okay, for the distance, we're waiting for them to catch up. We don't know really what the distance is, so that's just D. Okay, the time, we also don't know the time. So for Ben, it's T. And Carrie starts 1 hour later, so that's T minus 1. So Ben's traveling at 2 miles per hour, Carrie's traveling at 3 miles per hour. The time for Ben is T. Carrie is 1 hour later, so it's T minus 1. Okay, now we're trying to find out when Carrie catches up with Ben. So we have the first equation, D equals 2 times T. That's Ben's equation. We have Carrie's equation, D equals 3 times quantity T minus 1. Okay, we want to find out when Carrie is the same as Ben. So we want to find out when Carrie is the same as Ben. So Carrie is 3 T minus 1 and Ben is 2T. Or you can look at it as a substitution problem. D equals 2T and D also equals 3T minus 1. So we can make them equal each other because D and D are the same. Okay, then we do distributive property. 3T minus 3 equals 2T. We're going to solve for T. So subtract 2T here and add 3 here. And we end up with 1T equals 3. Okay, so it takes 3 hours. Except the question asked how long will it take Carrie to catch up with Bud. So even though T equals 3, we're going to have to put it in place of Carrie's time over here. And Carrie's 3 minus 1. So it actually takes her 2 hours. It took Ben 3 hours, but since she started an hour later, her time is 2 hours. So the actual answer is 2 hours. Example 2 is another catching up problem. A train leaves LA traveling east at 50 miles per hour. 2 hours later, another train leaves LA traveling in the same direction at 60 miles per hour. How long will it take the second train to overtake the first train? So again, it's catching up. You're going to make a distance equals rate times time table. This is the first train, this is the second train. The first train is going 50 miles per hour, that's the rate, and the second train is going 60 miles per hour. The first train leaves at T time, and the second train leaves 2 hours later, so that's T minus 2. Okay, so the first train's equation is D equals 50 times T, and the second train's equation is D equals 60 times quantity T minus 2. Okay, we want to know when the second train catches up with the first train. So we're looking for when this one equals this one, because that's when it catches up. So let's see now, 60 parentheses T minus 2 equals 50T. So that's 60T minus 120. Use this derivative property equals 50T. Okay, let's see. We'll bring the T's over here, so that's minus 50T. Bring the negative 120 over there, so that's positive 120. Okay, so now we get 10t. We have 10t equals 120. Divide both sides by 10. Divide by 10, divide by 10. And you get the time equals, t equals, 120 divided by 10 is 12. Except the question is, how long will the second train take? So you're going to plug this back into the second train's time. So that's 12 minus 2. So, because it left 2 hours later. So that's 10 hours. So the answer is not t equals 12, it's actually 10 hours because it's asking when the second train caught up with the first train. Okay, example 3 is opposite direction miles apart, and this is when the question's asking for how far, that they're going in opposite directions and how many miles apart. So example 3, 2 cars leave town at the same time, going in opposite directions. One of them travels 60 miles per hour and the other 30 miles per hour. In how many hours will they be 150 miles apart? So we've got the first car is going 60 miles per hour this way, and the second car is going the opposite direction, 30 miles per hour. Here's where they left from. Okay, so after 1 hour, they're 90 miles apart, right? Because one went 60, one went 30, so you add it together. After 2 hours, the first car is 60 and 60, 120 miles, and the other one's 30 and 30, that's 60 miles. So altogether, they're 180 miles. So the short way of doing this problem is you're adding up the 2 miles per hour. So 60, and we don't know the time, that's the rate times the time of the first car, plus 30, that's the rate times the time of the second car. They left at the same time. And we want to know when they're 150 miles apart. Okay, so 60t plus 30t equals 150. That's 90t equals 150. Divide by 90. Divide by 90. And you get t equals 150 divided by 90 is 1 2/3 of an hour. And if you broke that down to minutes, 2/3 of an hour, there are 60 minutes in an hour. So 2/3 of 60 is 40 minutes. So it's an hour and 40 minutes. But since the question asked how many hours and it didn't ask for minutes, it's 1 2/3 of an hour. Example 4 is same direction, miles apart. So the example is 2 cars leave town at the same time in the same direction. One travels at 35 miles per hour and the other 40 miles per hour. In how many hours will they be 15 miles apart? So we have the first cars going 35 miles an hour. And we have the second car going 40 miles per hour. Okay, same direction from the same place that they left. Okay, so after 1 hour, one's gone 35 miles, one's gone 40 miles, so they're 5 miles apart. After 2 hours, they would be 10 miles apart. After 3 hours, they'd be 15 miles apart. So in this case, it's actually kind of easy to figure out. But if you're going to do it with the equation, you take the higher one, which is the 40. 40 times the time. We don't know what the time is. We'll just pretend we don't know. Minus 35t, because we're looking at the space between here, equals 15 miles apart. So we subtract 40t minus 35t, that's 5t, equals 15. Okay, divide by 5. Divide by 5. And you get t equals 3 hours. So after 3 hours, they're 15 miles apart. Okay, example 5 is one with and against the wind. And sometimes you'll also see it with and against the current, like a boat. So a plane flew for 5 hours with a tailwind of 25 kilometers an hour. So that means the wind is helping push the plane. The return trip against the same wind took 6 hours, so it took longer because it's going against the wind. Find the speed of the plane in still air. So on this one, you're going to have to set up a distance equals rate times time table. So distance equals rate times time. Okay, we have with the wind and then we have against the wind. Okay, so with the wind, it took 5 hours. That's the time. And against the wind, it took 6 hours. Okay, now we have the plane plus the wind, which is 25. And then we have the plane against the wind, and the wind is 25. And the distance, we don't know. Okay, so we have two equations. The width equation is d equals, I'm going to put the 5 in front. P plus 25. And on the against, distance equals 6, and then P minus 25. Okay, and the distance is the same because we're going there and back. So we're gonna make this one equal this one, because one is going there and one is going back. So it's the same distance. So now we have 5p plus 25 equals the same distance as going back. Okay, then you do distributive property. So 5p plus 5 times 120 is 125 equals 6 times p is 6p minus 6 times 25 is 150. Okay, then we bring the p's together, subtract 5p here, and add 150 here. Okay, we end up with 275 equals 6p minus 5p is 1p. So that gives us how fast the plane is going. The plane is going 275 kilometers an hour. So 275 kilometers per hour.